Okay, we're on to the third video slash lecture on trig. As you'll see, I have a calculator on the screen now because it's important to know how to use a scientific graphing calculator such as this one to graph and just find the decimal solutions to trig functions. Yeah, we're going to go over how to use this calculator to compute things related to trig functions. I know that a lot of times in a class, you're just sort of expected to be an expert and know everything about the calculator. And when that day comes, they're just like, pull it out, it's time to go. But I had an experience when I was in school that somebody was just like, let's spend a whole, one of your study sessions instead of doing the math. Let me show you everything that the calculator can do. And I didn't become a calculator expert after that, but it really did change everything and made my life a lot easier. Let's see exact trig values. Okay, so like I said in the last video, we have these really commonly worried about or investigated angles, 30 degrees, 45, 60. So I went over the whole unit circle, back to exact values. There are certain sort of values that we know. Like I said, this is a known value. It's self-contained. It is square root of 2 over 2 forever. And, right, it's square root of 2, yeah. Whereas if you type, so let's type square root of 2 over 2 into this calculator. So we'll put the second function. This means it's like a shift key on a computer keyboard. So we do shift, and then that'll give us this blue thing. So if you do shift plus this X squared button, it's going to give you square root. Shift plus the little caret for raising to a power is going to give you pi here. So this is shift. So we'll do square root of 2. Then we're going to have to do a right arrow here because let's just do this. Okay, if I were to do square root of 2 and then I quickly hit divided by 2, well, what you're going to get out of this is 1 because it's doing the square root of 2 over 2, which is the square root of 1, which is 1. So make sure it can be sort of tedious, but make sure you do that. The square root of 2, you're going to want to hit divided by, but you actually have to get out of the square root and divided by 2. There you go. So this number is a decimal that will continue after this 812 here, but the Texas Instruments programmers decided to truncate it at this number of digits. I think it's possible actually to change the number of digits and get even more, maybe, depending on the calculator. I don't know about this emulator, but the number square root of 2 over 2, this is a number right here, an exact value, because again, it's assumed that the square root of 2 divided by 2 here in this fraction, this value that it is equal to, which is shown by an equal sign, includes all the decimals past this 812 here, all of them that exist. Whereas, so this equals some very long decimal value. Alrighty. Whereas this, if I were to write that 0.7071, it would be technically correct to give these little approximate equal sign waves to say 0.70710678112 something, right? I don't have to put the dot because I put approximately. So this approximate equal sign here is saying I don't want to write anymore, right? At any point here too, you can just round. So say I want to go out to this decimal because that's what either my professor asked for, which they probably won't ask for 6 decimals, but sine of 45 degrees is square root of 2 over 2. Exactly. If you want to give the exact value, then you also have this option going into our calculator. Sine of, what am I doing? 45 degrees. This is going to be in radians. So quick lesson here too is to hit mode here as I just did. I'll go back, hit mode and go down the radian degree there. It'll be different on different calculators, but on the TI-84 is pretty standard. Change this to degrees. I think it's clear to get out of there. And when I put in 45, it's going to give me 0.7072, an approximate value. This point at 45 degrees, if you do sine of 45 degrees, as we change the mode, you're going to get 0.707. And if you do sine of radian, here we go, sine of sine of pi, shift, and then pi over 4, you'll also get the same value. Now, I'm going to do something on the screen, which is an error. So don't learn this, just understand what's happening. If the calculator is under degrees, this is a classic fault that happens in a trig in a pre-calc classroom, is if you do sine of pi over 4, as your professor told you to do, then you're going to get the wrong answer. So this is bad. Do not do this. I'm not telling you to do this. I'm telling you not to do it. Because what you've done is you did sine of pi over 4 degrees, essentially, which then you just have this number, which is pi over 4, okay? You put into the calculator just now sine of 0.785-ish degrees, right? When you wanted to do this, and so you got the wrong answer. And another example is, say, cosine of 30 degrees is known to be root 3 over 2, exact value. And out of your calculator, you're going to get, let's check what we're on, degrees, good. You don't have to close the parentheses on a function like this. All right, it's about 0.866025 something something. And double check that that's true. We can also put this in the calculator. So we'll do shift, square root, then 3, get out of the square root, divided by 2. So root 3 over 2 is equal to that. So that lines up. All right, so let's just solve. Now, this one doesn't say specifically to use a calculator. We don't need to really use a calculator. Again, I would draw the unit circle and think about my 45-degree angle right there and think, okay, it's this 30 is okay. So you can either use the calculator on this one, or you don't really need to. You can opt not to. So when it comes to this, at this point, I'm just going to say, like for here, okay, I know that this coordinate right there is this set of coordinates for x and y is root 2 over 2, root 2 over 2, and both of them are positive. From this point on, like I said, I'll just pull that out of thin air, but I'll say when I'm doing it, this 30 degrees, here I won't write it there, but I'll say, 30-degree angle, 45-degree angle, and 60-degree angle. Remember that you can do this trick. You can go 1, 2, 3, 1, 2, 3, and then it's square root everything and put it over 2. Square root, square root, square root 2. Square root of 1 is 1, 2. That means the tangent of that angle is the y over the x, which is the same as saying this, as I expressed in the previous videos. And if you have this, you have 1, right? 2's cancel, the square roots of 2 cancel, you're left with 1. And then sine of 30 degrees, again, quickly, very quickly, but you'll need a unit circle or have it memorized. This is root 3 and 1/2. That's the x and the y coordinate. And sine is, a shorthand is just to say it's that y coordinate. And so the sine of 30 degrees is going to be that y coordinate. Sine is y, cosine is x. That's a good thing just to have. Again, another thing, this is something to just sort of, it's just burnt in. When you see cosine, you're looking at this, right? You know that you're thinking about this length, this, which is the piece of the x-axis that makes up the triangle, that makes up, that helps you find this position on the circle. And this y coordinate, right, is the height or the y of the triangle you're using to determine the coordinate on the circle right here. Okay, it'll always be like that. So what's the y coordinate? 1/2. So that means that this is 1 plus 1/2, which equals 3/2 or 1.5, okay? All right, and we'll go to the next one, which says to use the calculator, sine of 1. And when it says that, sine of 1, I have to assume here that this means 1 radian, because as you've seen in past examples, if you just have some value, which pi is a number. It's just, if you just see this alone, it's technically this or this, right? Technically, but it's just written as pi because it's saying the number pi is worth radians. And here it's a little bit of a shorthand. It's a little hand wavy. Whoops. But if this said sine of 1 degree, I would 100% know that it was in degrees. But if it just says sine of 1, I have to assume it's radians. Could be a typo. It could mean degrees to the person that wrote it. But like I said, conventionally they're wrong. So we're going to do it using a calculator. Let's clear. I always like to clear my screen. Like I said, it's in radians. So we go to mode, tab down to this radians and enter, and then get out with clear. Then we're going to do sine of, oops, that's an unnecessary parenthesis. Sine of 1, you can close it, but you don't have to. Sine of 1 radian is, here when it says rounded to 2 decimals, I'll tell you right now, if you are in a college trig class and you just write this, 0.84, you'll probably get this right. But, I don't know, it just feels good to me to be very thorough. It's just almost satisfying to know that the thing that I wrote in my paper, even if it's just for a professor and they're going to crumble it up and throw it out after I get the grade, just to know that the thing that I made is all the text on there is correct, which is a lot of times if you're rounding, it's not equal. I mean, this is not true. This is an untrue statement. This makes it true when I cross out the equal. That's true. This is technically not true. Like I said, if you have this certain professor, maybe they'll be a stickler, but odds are they won't care. If you want to be a professional, then you'll write sine of 1 is approximately, and again, even this is sloppy, I did it without the 0 on purpose, is approximately 0.84, boom, it's rounded to 2, all right? And then we want to find the exact value of cosecant of pi over 6. I happen to know from previous videos that this is 1 over sine of pi over 6. And I also happen to know from being a unit circle expert, which you will soon be, that pi over 6 is right here at 30 degrees. And that coordinate is, I just wrote it, root 3 over 2. Once you realize, like, okay, it's 30, 45, 60, and you realize that the only values that are really in there are 1/2, right? Root 2 over 2 and root 3 over 2. If you have these as your conventional angles that we care about, this is what's going to pop out all the time. So, like I said, when I'm here on this unit circle and I'm saying, what's cosecant of pi over 6? Okay, now I have sine. This is something I kind of know off the top of my head, whereas this, I don't. Sine of pi of 6 off the top of my head is 30 degrees. And I can verify what this sine y coordinate here is. Remember, this is the y coordinate. This is sine of theta and this is cosine of theta. Technically times r, but on the unit circle, r is 1. Okay. This sine, the coordinate, the y coordinate is going to be the height, right? And so this is all happening quickly, and you'll get this down too. Is, okay, my x coordinate is this at 30 degrees, pi over 6, right? My x coordinate is this, which is large looking relative to this y. And the y is kind of, let me get rid of this. The y is kind of short there. See, it's small. So again, when we're working with these values, this is what, 0.866. I have a calculator right here. Should have root 2 over 2 down by now. I think it's 1.414, right? Root 2, divided by 2. Sorry, it's half of, if you double that, then you have 1.414. which is the square root of 2. So 0.707 and then 0.5, right? You know that you're looking at the short and the longness of it, where here they're the same length. Here the x is clearly short and the y is clearly long. Here the x is clearly long and the y is clearly short. So if you do a quick sketch of a unit circle on your exam, then you'll say, okay, this distance here is the long one. The biggest thing is root 3 over 2. So you already know that the long x is root 3 over 2, and then this short piece is 1/2, the smallest number, if that makes sense. And so, like I said, if say we're on an exam and God forbid I forgot that what cosine of 45 degrees is, which should never happen. It won't happen to you either. But if you do forget, you can go, okay, 45 degrees here. Okay. And as time went on, like I would sketch way more sketchy, right? It would just be like boom, boom, boom. Okay, okay, what's this? Okay. This is 2 over 2, 2 over 2. Got it. And the reason, justification in my head real quick, I'm like, wait, is that right? I don't remember. Then I can be like, okay, the height of this triangle looks approximately equal to the width. So the x and the y are the same length, which is true right there. So anyway, back to the problem. And so if in this particular problem I needed cosine of 45 degrees quickly, but I didn't remember root 2 over 2, then I could do all this to justify it and be like, okay, the x coordinate is related to the cosine, y coordinate is related to the sine. Okay, my x, this is it. It's this. Boom, quick sketch. But here we're working with sine of pi over 6, which is 30 degrees. And we've determined that the height of the triangle right here, which is the sine of theta, is 1/2. So this is equal to 1 over 1/2. And again, we went over this. 1 over 1/2 is equal to 1 times the thing flipped. So 1 over 1/2 is 1 times 2, and so it's 2. So the answer is 2, which is B. Okay. All right, next it looks like we're interested in functions. So I didn't go really into functions at all, picked examples that really didn't rely heavily on that. But most of the time you'll take a trig class in tandem with a pre-calc class where you will have learned all this, or in a college math class, you'll have learned all this function stuff. So it says, given these two functions here, find the exact value of the expression if theta is 60 degrees. So this is just asking for f of theta, which is defined right here as sine of theta, so we can write that. And then in our example, we are using I can even write this formally and say, since theta equals 60 degrees, comma, you can say, okay, and sine of 60 degrees, we want an exact value. We'll do this right here. It goes 30, 45, 60. This one up here, I know it has a short x, right? So it's got to be 1/2, comma, tall y here. Sine is the y value. So the answer is root 3 over 2, and that's exact. So f of 60 degrees is root 3 over 2. It's just the same as saying sine 60 degrees is root 3 over 2. It's just trying to get you comfortable with how to work with functions as they are written. Yeah, so if this same thing, if theta were 30 degrees, then we would solve it the same way by saying, okay, f of theta equals sine of theta, that's the function. And then since theta is 30 here, right, this is a new problem. Since theta is 30, f of 30 degrees is sine of 30 degrees, oops, which is here, we did a second ago, which is 1/2. All right, so then we'll do g. It wants g of theta over 2. We're still assuming this to be theta equals 60 degrees. G of theta is the function cosine of theta. So g of theta equals cosine of theta. And theta is equal to 60 degrees. So these are our givens. And g of theta over 2, well, we have a function called g, and we're performing that function on theta over 2. Theta is 60 degrees, so g of theta over 2 is equal to g of 60 degrees over 2, which is equal to g of 30 degrees, which is equal to cosine of 30 degrees, because g is just cosine, right? Which is, back to our unit circle, long x here at 30. So I know it's root 3 over 2 because that's the big number. And then they want you to square it here, so we will continue to write this because g of theta is cosine of theta, okay? Theta is 60 degrees. G of theta squared is going to be step by step here. So last time it had us do an operation on this, right? This one was g of theta over 2. So it did an operation on the argument itself. We changed the argument of our standard general function of g theta. We changed the argument. That's this part in here. We changed the argument to theta over 2 and then solved. Here, the argument is actually staying the same. So the only thing that's going to change is after we write the function, so g of theta, we write right here, cosine of theta, right? So we've just turned this g of theta to cosine of theta because it's true right here, they're equal. And then we just add this part, a little square. And if you have cosine theta squared, you get the function cosine squared theta, which will go more into stuff like this. Stuff like this is all possible. Identities. I don't know if I did identities, but I definitely need to. So let's see, find exact value. So here it's warming us up off the calculator, and then I'm sure it's going to give us some calculator ones. Find the exact value of each expression. So exact already tells me we're not using the calculator because the calculator doesn't give us exact answers, but this calculator is just going to give you a decimal. So this is actually, we already know we're not using a calculator because it wants an exact value. So what we're given is 2 times sine of 45 degrees plus 4 times cosine of 30 degrees. And the parentheses here are kind of optional, depends how you feel. I'm just going to straight up write a unit circle for each of these because it's just the way, you know. You're on your homework and your exams, your margin should have multiple unit circles if you're in a trig class. So sine of 45, like I said, 45 degrees here. It's the one where the lengths are the same. And for that, of my options, right, it's got to be the one where it's both the same, which is root 2 over 2. It's the only time that happens, right? So we have sine of 45 degrees, which is the y-coordinate, 2 times sine of 45 degrees. And we'll do another one right here, even though I already have a unit circle, just to show you how easy it is to do one quickly. 30 degrees here. We've got a long x, so that's going to be a root 3 over 2 for the x coordinate, which is what cosine is. So plus 4 times root 3 over 2. So this is here. And now we just have to do a small little bit of math. So 2 times root 2 over 2 is the same as doing this if it is a nice visual aid. So these cancel. And that means we're left with root 2 over 1, which is just root 2. And this is 4 times root 3 over 2. So 4 and 2 are going to reduce to 2 root 3. Right? That should be an acceptable answer. It's exact. It may seem less exact than just having this, right? Or just having this. It might seem less exact because it has addition inside it. But again, this is your root 2 is 1.414. Some other numbers we don't have written down right now. Plus 3.464, more values that we don't have. Eventually go off the calculator. This is inexact. This is exact. Or another way to say inexact is approximate, right? If we're approximating, we have this. The exact is if we just leave the symbols. And then we have one more. It wants us to find what the exact value of this quickly. Tan of 4 over pi is 45 degrees, pi over 4. The coordinates are root 2 over 2, root 2 over 2. Tangent is y over x. So we have x and y. Then that means this is y over x. So that's root 2 over 2 over root 2 over 2, which is the same as root 2 over 2 times 2 over root 2, which is the same as 1. So tangent of pi over 4 is 1. And then the cotangent of pi over 4 is, as we know, 1 over the tangent. And if the tangent is 1, then the cotangent is 1 over 1, which is 1. So that means this answer is 1 plus 1 equals 2. Here we want to practice using a calculator, which is fun. So we have first step, mode, check, always check. Just, you might think, I don't want to hit mode, I don't want to check, but it's just worth it. Mode down here to degrees, enter, okay, because we're working in degrees right here. Then we'll get out of there, and we're just going to click cosine, or you're going to tap it when you're using your fingers. Cosine of 14, the units are assumed to be degrees in here now. And so the answer to this, round the answer to 2 decimal places. And if you want to be particular, you write this. It's about 0.97. And then what's cosine of pi over 8? Well, pi over 8 is in radians. So mode, radian, get out of here. What are we doing? Cosine of, and then the caret right here gives you pi over, which is divided by 8. You don't have to close parentheses, but I'm doing it. Cosine of pi over 8 radians is approximately 0.92. And the cotangent of pi over 18, we're still in radians, so we don't have to change it, is, there is no cotangent button on the calculator. So I'm actually erasing my approximation equal sign. I'm going to write, this is actually equal to 1 over tangent of pi over 18, right? That's exactly equal to that. And then once we use the calculator, it's approximately equal to tangent of shift and then pi over 18, approximately equal to 0.17632 something. It's 1 over that though, right? 1 over the tangent of pi over 18. And so this value, what you can do is 1 divided by answer, or a quick solution. You just go boom right there. When you click that button, it's automatically going to put in the answer that you just got and take it to the -1 power, which is the same as doing this, 1 over the thing. This equals 0.17632 to the -1, as we've discussed in previous videos. Quickest way to do it, you want to get the inverse of that number. There you are, which approximates to, that's your answer. And that should do it for this one. I'll see you in the next video.